So 9.2. So a reflection, the way we're going to describe reflections with math is we're going to say a reflection. Well, the first thing we need for a reflection is a mirror. So we're going to reflect across a line. So we call it line M. And line M is either the mirror line, I think that's the term that you'll hear the most, or the line of reflection. Usually you'll hear mirror line, is a transformation. And I could say a rigid motion, transformation, rigid motion, is a transformation where these things happen. Any point on the mirror line is its own image. So we're saying A equals A prime if it's on the mirror line. So that's like if you have a sticker on a mirror. The reflection of the sticker looks like it's in exactly the same place as the sticker is on the mirror. So any point on the mirror line is its own image. Any other point so we have some point B not on the line. Is the same distance from M as B, and the mirror line is the perpendicular bisector of B, B prime. All right, I hear music. I shouldn't hear music. So let's draw a picture to tell us what this is talking about. There's my mirror line M. And it says if we have a point on the line, there's point A. The image of A is A prime. It's the same point. And if I have some other point B, the image of B, it says it's the same distance from the line. So we go straight towards the line. And by straight towards the line, we mean we make a 90-degree angle. And we go the same distance to the other side of the line as B is on this side. So there would be B prime. And we're saying that these two segments are congruent. And if we had another point C here to find the image of that one, I go straight towards the mirror line, make a 90-degree angle, and I go the same distance to the other side of the mirror line. There would be C prime. These two are congruent. And if I drew that triangle that I made, here's my original triangle. There's ABC. Oops, undo that. And then A prime, B prime, C prime would be like that. And that would be the reflection of ABC over the line. And we write capital R for reflection over line M of triangle ABC equals triangle A prime, B prime, C prime. And usually we write the equation of mirror line. So the second part here means we go straight towards the mirror line and we go the same distance to the other side of the mirror as we are in front of the mirror. If you look at yourself in the mirror, where you are in the mirror is the same distance on the other side of the mirror. And if we know the equation of the line, I'm going to switch pages here. If we know the equation of M, we can write the reflection over the line y equals x, for example. Or we could write the reflection over the x-axis. Or we'd write the reflection of the line y equals 3x plus 5. So we put the equation of the mirror line down there on the bottom. And reflecting across the x-axis and the y-axis is pretty easy. That would be my suggestion for your project. Just choose to reflect over the x-axis or the y-axis, because those are pretty easy to do. All right, questions? All right, I'm going to draw a picture. I have a question for all of you. Now imagine that these pictures that I draw are beautiful and perfect. I'm going to draw some trapezoids. And we want to know which ones could be reflections. I'm going to call that 1, 2, and 3. And just imagine that all of these are beautiful and exactly the same size and everything. So which ones could be reflections? 2 and 3 could be reflections. What would be the mirror line there? The y-axis. So we'd say the reflection across the y-axis of 2 equals 3, if we use our imagination and see my pictures are beautiful. Why can't 1 and 2 be reflections? It's a translation, right? If we reflect this top part of the trapezoid over the x-axis, it would have to be further away from the x-axis than the base, so that the distances don't work out. Could 1 and 3 also be a translation? Yeah. So this is kind of an example of what you might do for your project. Is you might say, okay, I'm going to translate my shape this way, and then I'm going to reflect it that way. Yeah. It's an individual project. All right, questions there? Okay, let's translate some points. Or sorry, reflect some points. We translated points on our opener. So we have a point F, which is at 2, 6. And we want to reflect across the line y equals 3. We want the coordinates of this reflection. Well, let me draw a little picture to help us out. There are my axes. What kind of line is a line y equals 3? How would I draw the line y equals 3? What did you say, Anya? A horizontal line, yes. Line y equals 3 is a horizontal line. So here is the line y equals 3. Y equals a constant is a horizontal line. And here's my point 2, 6. Here's point F up here. And we're reflecting across that horizontal line y equals 3. So if we reflect across this horizontal line, does our point go left or right at all? No, it's just going to go straight up or down. So I need to go straight towards my line, towards my mirror line. How far do I have to go from 2, 6 to get to y equals 3? I go 3 units. And then if I'm going, I need to be the same distance below the mirror line as I am above. I need to go 3 more units this way. So where does that put me? At 0. So F prime would be here on the x-axis at the point 2, 0. Because I reflected across a horizontal line, the x and y didn't change. And I had to go 3 units to get to the mirror line, so I had to go another 3 units down to get to my new point. So I would say the reflection across the line y equals 3 of 2, 6 is 2, 0. And if you chose to, on your project, reflect your figure across the line y equals 3, you would do this process to all your different points. Okay, questions? Right, before our next example, one quick reminder. Reflections are rigid motions. Reflections, whatever figure we have reflected, is congruent to our pre-image. The image and the pre-image for a reflection are congruent. Reflections don't change the size or shape. So we're not reflecting in circus mirrors. We're reflecting in nice flat mirrors. All right, I just want to do one example of reflecting an entire figure. So you can kind of see the process that you're going to use in your project. So I'm going to say triangle XYZ has vertices x is at -4, 3, y is at 2, 6, and z is at 1, -2. We want to find the vertices of the reflection over the x-axis of triangle XYZ. So let's draw a picture. So x is at -4, 3. Y is at 2, 6. And z is at 1, -2. So there's my triangle. And we want to reflect it over the x-axis. Well, if I reflect over the x-axis, do I move left or right at all? No. I'm just going straight up and down. So x, I'm going to go straight down to the x-axis. That's my mirror line. and I'm going down 3. To get to my new point, I have to go down 3 more. So x prime is going to be at -4, -3. Y prime. I'm not going to move left or right. I have to go down 6, and then I have to go down 6 more. So y prime is going to be at 2, -6. And for reflections, we think of the mirror as being two-sided. So z is going to reflect up instead of down. So I go up from -2 to the x-axis. I go 2 units, and I have to go up 2 more. So z prime is going to be at 1, 2. And my reflected triangle would look like this. And that would be the reflection of that triangle over the x-axis. And I'm just going to list them here. X prime was at 4, -3. Y prime was at 2, -6. And z prime is at 1, 2. All right, do we see what did we do to these to get a reflection over the x-axis? Same thing, except we changed the signs on y's. So to reflect over the x-axis, we change signs on y. So we just have to go and change all the signs on our y coordinates, and we have a reflection over the x-axis. What would you guess we're going to do then if we wanted to reflect over the y-axis? Change sign on x. So to reflect over the y-axis, so for your project, that's what I would recommend, is do a reflection over the line, like over the x-axis or the y-axis. And that way you just have to change the signs on one of your coordinates for all of your points, and you have your new coordinates. So there's really not much to do to come up with your coordinates, and you just have to plot. Now I have had students choose a different line. They choose y equals x, or they choose some other line just to make it more interesting, and that's fine. It makes the project a little more interesting. All right, questions? Okay. And on your homework, there are a couple of problems, or at least one, where they ask you to reflect over the line y equals x. So what you can do in that case, the line y equals x is a diagonal line like this, and they give you those points on a graph. What you can do to reflect over the line y equals x is count diagonally across the squares to find your new point. So if this is diagonally across 3 squares, you want to go diagonally across 3 squares to get to your new coordinate. So to reflect over the line y equals x, you just count diagonally. All right.